We have three things on the agenda today. First of all, to get you a little bit familiar with TopCoder, which you're going to start using in the lab tomorrow. Two, to get you a little bit experienced with Stringstreams. And three, to get you some experience with command line arguments. And you should have seen Stringstreams and command line arguments in 102, but I know they may be a little bit vague in your memory, so we're going to go back over them. In fact, I think I'm going to use my 102 notes to quickly review them, because you can read Dr. Planck's notes, but his notes kind of assume you already know something about string streams. Many of you, I've already seen a couple questions indicating a little bit of uncertainty about string streams, so I just plan to go over my 102 lecture on them. If you have a computer with you, please go to the TopCoder. So go to my lab. Not my lab. Go to my lecture. Go to my course notes, and you'll see TopCoder problems. Click on TopCoder, and you'll see that you can download this particular applet. Please do that now. It should take at most 30 seconds or so. And once you download it, try to open it. It's not going to work in every case. And if it doesn't work for you, if you're on a Mac, I have a possible solution, but it may be that you don't have a version of Java running on your computer, in which case you'll need to download that version of Java. And I can't deal with, there's like 40 or 50 of you here today. I can't deal with that many of you. So you'll have to go to office hours if you can't figure out how to download Java yourself. If you're on a Mac, so once you've done the download, okay, on a Windows box, you should be able to find it. On a Mac, you can just go to the downloads folder, and it should be there. You should be able to double click on it. And if you're on a Mac and you're lucky, it will start coming up with this. And if on a Windows box, it will start coming up with this applet. You'll have to give it a couple, maybe again 30 seconds or more for it to come up. It's not the fastest thing in the world. So you should see a screen that looks like that. For Mac users, if it quits, it starts to seemingly come up and then it quits, what you can do is push the control button down. Then click again. Whoops, darn it. This is opening because I've already told it it's okay to open. Let's do here. Ah, shoot. Well, what you'll have to do if you're on a Mac is Control left down, and you'll get a menu. And you should then scroll down to the Open option. You should click Open, and then it will pop up a dialog box saying, can I trust it? Run it or not? And you should say trust it and run it. The problem is Macs are very suspicious of anything not distributed through the App Store. So they're trying to protect you by not running it. And by doing that control click trick, you should be able to force the Mac to force open the applet. Okay, so once you have the applet up, you should be able to log in using your TopCoder account that you set up last week. Okay, if you can't, just follow along with what I'm doing here. Okay, I see a bunch of people entering the room, so it looks like at least some of you are able to get in. Just a show of hands, how many people have been able to open the applet? Okay, very good, so that's promising. How many have been able to log in? Okay, that's encouraging. If you get a message saying you need to do Java or download Java, please go to the office hours and the TA can help you with that. We can't do that right now. It's going to take too much time. Okay, so once you're in the, once this has come up, there's a menu line at the top, and one of them says practice rooms. Okay, you should click on that, and then you see a, if you click down, you see SRMs. This is where you will be able to locate the problem we want you to work on. Now, an annoying thing is that, look at, for today, what we're talking about is SRM 564, which are faux palindromes. So if you go to 561 through 574, do you see SRM 564? I know it's kind of hard to read up there, so you may have to read it on your screen. You don't, do you? The SRM numbers in the sequence 570 to 575 are actually SRM 416 through 430. So that's a little confusing. What you have to do is you just have to start scrolling down until you find the SRM that is really 564, which is way down in 851 to 875. I don't understand their numbering scheme, but it is what it is. So actually their problem that is numbered 854 is the one we want, which is SRM 564, and we're generally going to do Division 2 problems in this course. Normally you'll see a Division 1 problem and a Division 2 problem. We're going to be doing Division 2 problems. They're the easier problems. So once you have located in the practice room SRM 564 Div 2, you should select it, and you'll see a loading screen. And you now will be asked to select a particular point. So you can go for the 250-point problem, the 500-point problem, or the 1,000-point problem. And as you might imagine, the complexity of the problem increases with the number of points. So again, in this course, we'll typically be going for the easiest problem, which is the 250-point problem. So if you click on the 250-point problem, it comes up with a 2-pane window. I know in my case it's only coming up with a 1-pane window, but if you click, there's a couple buttons at the bottom, arrow keys, and if you click them, you can go back and forth between your coding area and the problem statement. Of course, you can also resize the window. So the first thing you always want to do is, of course, read the problem statement to find out what the problem is all about, which in this case, we're trying to detect what are called palindromes. So a palindrome is a string that reads the same either forwards or backwards. Any Annas in here? Nope, no Annas. Well, if you were an Anna, you would have a palindrome for your name, because if you look at Anna, either spelling A-N-A or A-N-N-A, either way, if you read it forward and backwards, it's the same word. So that's a palindrome. Now, the problem is saying that if we just did it that way, it's a pretty easy problem. So the problem is saying we're going to be a little bit trickier. Is that a palindrome, according to what I just said? No. It doesn't read the same forward or backwards. But the problem statement says replace any block of repeating characters with just that character. So in this case, we have a repeating block of A's, so we should just replace it with a single A. We have a repeating block of N's, so we'll just replace it with a single N. And then we have a single A. Is that a palindrome? Yes. So that is what the problem description calls a faux palindrome. It's a palindrome that you arrive at by, in effect, collapsing a sequence of similar characters to a single character. So the problem is saying, given a string, output one of three values for that string. Either output the word palindrome if it is a true palindrome, the word faux palindrome if it is a faux palindrome, or not a palindrome if it is not either a palindrome or a faux palindrome. Yes. Then you print out palindrome. So Anna, this one, is both a palindrome and a faux palindrome. But since it is the real McCoy, we actually print out palindrome. Okay? Just like my poor dog is only a half pit bull. She's half pit, half hound. So the real McCoy pit bull wants to be called a real pit, just like the real palindrome wants to be known as a real palindrome, not a faux palindrome. Okay? So that's going to be one of the things. Dr. Planck has gone through kind of his version of coding up this problem. And so, but before we do that, it's useful to go through and read the problem description. They give you a definition, and in particular, they give you the method signature. So the method signature tells you the name of the method that you're going to be writing, the function prototype, so to speak. And you have to make sure your method is public. There are some limits which we're not going to have to worry about in this class, namely that your program run in 2 seconds, faster than 2 seconds, and that you use no more than 64 megabytes of memory. That won't be an issue. Then the constraints are often helpful in being able to solve the problem. So in this case, it says that the word contains between 1 and 50 characters and that the characters will be uppercase. So you don't have to worry about lowercase characters or punctuation. It's guaranteeing you don't have to do error checking. Okay, it's guaranteeing your input will be between 1 and 50 characters. And then it gives you the examples, which are very important to look at. Okay, so the first 3 examples, palindrome, a faux palindrome, not even faux. So that's what your output looks like. Then they start giving you some more complicated examples. Okay, and so on and so forth. So once you kind of figure you have an idea of what to write, it's time to start writing. Now, notice up here it says choose your language. How many of you have, is it checked Java for, as opposed to C++? Very important. Before you begin your coding, check C++. Otherwise, it's going to use a Java compiler on it, and it's not going to work. Okay? So, once you do that, I'm going to switch back to my TopCoder problems. Okay, so you're ready to start coding. So how many, I actually don't have I do something to force the TopCoder to download the problem to my personal machine, and I use an editor. And Dr. Plank has some notes that tell you how you can do it. But for this problem, he's showing the coding area. I'm just curious, does anything come up in the coding area for you? Anything like a class, or is it empty? Okay. So in that case, what you have to start doing is typing in the class declaration. And it has already told you what that class declaration should be down here in definition. So it told you that the name of the class should be fall or full palindromes. And the name of the method should be classify it. And it even gave you the method signature. So the first thing you should do is you should actually create the class declaration. Okay, so this is the way we taught you to do it in 102, which is to separate the class declaration and the function definition. So the function definition is being put outside of the class declaration. And you can see that the class has a single public method called string classify it. And then we provide initially a very simple function definition. Obviously, it's not going to work for every case. Okay, it's going to sometimes get lucky, but we just want to get something that will compile. So hopefully while I've been talking, some of you have been busy entering it. If not, well, just hang on. I'll give the people who are entering it a minute or so. When you're done, you'll notice there are some buttons at the bottom right. Okay, one of them is the compile button. Okay, click on the compile button. And actually, it may help. You also probably should first click save to save it, because it does not actually save for you. So first thing you should do is click save to save it, and then compile to compile it. Okay, and if you exactly followed what is up here, it doesn't compile properly. Does anyone know why? Here, I'll show you the error message. Error on line 10, no std : string full palindromes classify it. Line 10, if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, not very helpful because line 10 is actually beyond the end of the program. But it's saying it can't find any thing with this particular thing with a capital C. The problem is very subtle. Here it was declared with a lowercase c, here with an uppercase C. What's the moral of the story? C++ gives you horrible compiler error messages that really aren't very informative. But that was the problem. It indeed could not find that function in the class declaration because it didn't exist. The C++ compiler is picky about those upper and lowercase characters. Okay, so if you fix that problem, and the function, the problem specification said you were to use a lowercase c. So if you fix it, you can, it should compile with a warning, which you shouldn't worry about for the time being because you're not yet using what the warning is saying that you're ignoring the parameter string, which indeed we are. We're just returning palindrome. We'll fix that problem, obviously, so we can ignore the warning for the time being. So now you can, once you've got it to compile, you can go to the test. So down here, there is a test, and you can select an example. So they have a number of different examples. So here's the TopCoder one. You hit OK, and mine's already correct. So it's saying correct return value, yes. Return value, palindrome. So it agrees. But if you do it on your computer, you'll find if you test example 0 that it will work, because just by happen chance, Anna is a palindrome. But what happens if you run it on example 1? Someone tell me? It's not, mine works, but what happens? Anyone that far? Nope. Okay. Well, I'll show you what happens. I will return, actually I have to do it outside of it. So I'll do my coding outside and say string returning palindrome. Okay, so if I compile it, I get an error message. And the error message is because I forgot my include. Okay, why would this give me an error message? I have my include statements, but it's telling me it can't find the string. It says string is undefined. But here it is. I included string. So why is it telling me that string is undefined, undeclared? Using namespace std is absent. So I have to add using namespace std. Okay, now I try to compile it. And it says unused parameter, but that's okay. So I run test, and I'm going to run it on example 1. And when I run it, it says correct return value no, return value palindrome, but that's not what it expects. So it doesn't tell you what the right answer is, but it does tell you that the answer that you provided is incorrect. So that means that's no big surprise, right? We can see that example 1 is a faux palindrome. We were just trying to get it to the point where it was working, so we did. Now we have to go to work on the actual program. Okay. At this point, you're not going to be able to enter the program, so don't even try. But we're going to go through what he did. So what he did initially was he was simply getting rid of the blocks of characters. So if you had AANNA, what he's doing is he's creating a vector. So he's creating a vector t, and what he's doing is he starts with the first character and he pushes A onto the vector. Okay, then he goes to the second character and he says, is that second character the same as the preceding character? If it is, I'm not going to push it onto the vector because I'm trying to collapse blocks of similar characters. So, actually I'm too far. I'm ahead of myself. Am I? No, I'm not. This is it. Okay, so we started by pushing back the first character, which was A, and then for all the remaining characters, he checks to see whether the current character is the same as the preceding character. If the current character, which is in this case A, is the same as the preceding character, we're just collapsing this block, so we don't add it to the vector. Okay, we get to the next one, and it's still an A, so we're still not adding it. But when we get to N, for the first time, this condition is true. Correct? And N is not equal to the previous character, which was an A, so he pushes N onto his vector. Okay, then he goes to the next character, which is N. This is all being done in this loop here. Asks, is this N equal to the previous character? Yes, so I do nothing. Comes to this A, is it the same as the previous character? No, so he pushes A onto the vector and we're done. So this part right here is now finished. Okay, now what he needs to do is check to see whether this thing is a palindrome. How might you go about that, you think? How might we go about it? What's the definition of a palindrome? Reads the same going forwards and backwards, right? So, should the first and the last character, can they be different if it's a palindrome? No. So what do you think we should start with? Perhaps. Checking the first and last character, perhaps. So the idea is that we're going to keep two pointers. One is going to point to the beginning of the array, and one is going to point to the end of the vector. And what we're going to do is compare the characters and make sure they match. If they match, we'll decrement the j and increment the I. So let's say it was a slightly bigger one. Let's say it was A, B, N, B, A. So what Dr. Planck has done is created two subscripts, I and j. He compares them, they're equal, so now he increments I so that it points to the next point one, and decrements j so it points to the previous entry, and again he compares them. B and B are equal, so again he decrements them. Now I is equal to j, and of course in that case they're equal, and once they cross, he's done. He knows it's a palindrome. If at any point they don't match, it can't be a palindrome. So his next code, that's what he's doing here. He's simply setting I to point to the beginning of the vector and j to point to the end. Now you might wonder what he's doing with this cout statement. Okay, what he's doing with the cout statement is he's printing W and then he's printing T. So this is just to verify that he's doing the right thing. TopCoder ignores your cout statements. That's a very nice feature of TopCoder. When it does its tests, it will print the results of your cout statement so you can see do this kind of testing, but it ignores your coutts in comparing the results. So it does a diff between what your return value is, what the string return value is, and what it expects the return value to be, but it disregards all your standard out. That's handy because you can print out debugging information. That's all he's doing there is printing out debugging information. He's printing out the input string and he's printing out his vector t. Okay, actually, I'm sorry. T was declared as a string, and a string can be treated as a vector. So what he's doing is actually treating his string as a vector. Okay, so questions about that? Okay, so this while statement is just doing what I told you. If there's a mismatch, it returns not even full. If they are equal, he increments I and decrements j until they cross, or until they become equal. If they become equal, they're obviously the same. So he continues as long as I is less than j. Once I becomes greater than equal to j, he knows he has a palindrome. So he then asks, is t equal to w? If it is, he returns a palindrome. Remember your question? You said if it's both, which one do you do? So he first checks to see if t is equal to w. If it is, he returns palindrome. If it not, he returns full. Okay, so he compiles it. And it compiles properly. And at this point, you also have to hit save. Actually, this is really important. When you have finished editing, first do save. If you don't and you hit compile, it will compile your old version. So remember to hit save, then compile. Okay, once you're ready to submit the same sequence, hit save, and then compile, and then hit submit. Submit submits it to the TopCoder system for testing. Okay, so the submit button, which is down here, lower right-hand corner, submit, allows you to submit it for testing. Now, TopCoder is a time competition, so the faster you finish, the more points you're eligible for. So it's a 250-point problem because it took some time to write it and test it. We're only going to get a maximum of 213 points. So don't worry about the stopwatch, but if you were competing in TopCoder, there is a premium on speed. The faster you get it done, the more points you get. But just because the submission succeeded doesn't mean that it did not run the test suite. It just meant it stopped the clock. And now what you need to do is you leave the TopCoder arena and go back to your original splash screen. And on that original splash screen, next to practice room, there is practice options. And the third option is run system test. That runs an exhaustive series of tests on your function that you've written. Okay, so you can see that the first three succeeded, but test cases 3, 4, and 5 bombed out. Well, you can go and click on any of those test cases to see what the string looks like. So in this case, the string is xxx, y, tyy, ttyx, and it expected to get full as the output, but you returned not even full. Okay, this seems pretty odd because it looked like we were testing. You're thinking, well, we were testing to see whether the character at the beginning was equal to the character at the end. Does anyone see the very subtle error there? What's the name of the original string that we're testing that was input as a parameter? Nope. W. And what is the name of the string where Dr. Planck was putting the collapsed string? T. So the problem is he's not looking at T, he's looking at the original string W. That's why he's getting a bug here. Right? He's supposed to be looking at his collapsed string T. So the bug is he's looking at the original string rather than his new string. So he goes ahead and he fixes the problem. So he changes the test to compare TI and TJ. And he resubmits it because he's on a competition. But resubmitting does result in a penalty. That's a drag, but no way around it. So not only do you get a 10% penalty plus, but the time is ticking again. So he's down to 177 possible points now. So again, he runs his system tests, and he was close, but test case 4 still failed. And he's pretty, I do like his notes, dang it. So double clicks. And it expected a palindrome because TopCoder is a palindrome, but instead he returned full. Okay? Well, the problem is that he never checked, just a second. If we go back to his code, what he did was he never checked W originally. That's not showing up. Right, he never checked W before he collapsed the characters. So he really, before he ever collapsed the characters, right there, before collapsing the characters, he needed to check to see whether the original string was a palindrome. So before collapsing characters, you must first check to see if the original string.
It doesn't matter where you do the check, you just don't check.
Sure. That's true, but for efficiency purposes, you'd really rather do the check first rather than later. So you don't want to do unnecessary work. So you're right, you could do it after you collapsed it, but we worry about efficiency of our programs. Okay, so he adds that check. Right here. So he's just going through W using the same strategy as before. He declares I and J. I points to the beginning of the string. J points to the end. He moves I and J toward each other. If he ever encounters a character that is different, then he sets is Pal to be false, and otherwise, so when he gets out, if is Pal is still true, it's a palindrome and he returns. Otherwise, he checks to see if it's a faux palindrome. Okay, one little plea for you. Dr. Planck is old school, and he uses ints for his Boolean values. Hence, he declared is Pal to be an int. If you're going to use a Boolean variable, please, for me, declare it as a bool. It's just good to do it that way. Yes, I know that Dr. Planck will use ints for his flags because he's old school, but I would prefer that you use, actually this should have started out as true. I would prefer that you declare your flags as bools rather than ints. It's just, if you don't and you get out into the real world, your boss is probably going to tell you to do it. So it's just good to get in the habit of declaring your flags to be bools. It's a minor thing, but it is what it is. Okay, so finally success. After another save and compile and submit down to 132 points. As I said, I do find him amusing. That is a sucky score for such an easy program. Whatever. So after a few seconds of anxiety, he finds that it passed with a nice green. Yay, we're done. Okay, so please read my comments about TopCoder. Dr. Planck also has some comments, but I discovered some gotchas when I started using TopCoder. I used it for the first time last spring. So there are definitely some gotchas. The biggest one being you have to make sure that you hit save before you do submit or compile. And the other big gotcha is that it assumes that you want to use Java rather than C++. So you need to remember to click the C++ radio button. The other gotcha is that as the problems get more complicated, sometimes you're going to write infinite loops. And you won't find out about the infinite loop until it runs the suite of test cases. It does not stop when it finds the first bad test case. It runs all 250 of them, or however many it runs. And if you're in an infinite loop, I think it only cuts you off after 2 seconds. So if you're running, say, 50 test cases and each takes 2 seconds, unfortunately, if you've written an infinite loop, it's going to take about 1.5 minutes for it to return. That's why I say you just have to be patient. It's not hanging. If it doesn't return immediately, just take a break. It'll be back. It's just probably you wrote an infinite loop. Then Dr. Planck has some comments about TopCoder, the biggest one being that it is a speed-based competition. They don't grade you on the elegance of your code. His point being that when you're writing a TopCoder problem, you focus on getting it right, but when you're writing your lab, you focus on elegance. So when you hand in your lab, we want it to be efficient and elegant. To your question, in TopCoder, if you're rushing and putting that test for the palindrome at the end, that was fine. But in your lab, we want it at the beginning. So in the lab, write elegant code, but in TopCoder, try to get it to work. And he said that's where you just need to know what the difference is. If you're on a deadline and you have 24 hours to get something done, you write it to get it done. But if you have a little extra time, you should write it elegantly. Okay, that's why he said back here, where he wrote his final fix, this code and this code is the same. So he should have written a function for that piece of code rather than writing it twice and then simply called the function. That would have been elegant. But instead, he simply wrote the same piece of code twice. Okay? Can someone tell me why it's more elegant to write a function here, other than the fact that it just saves a little bit of space? Why in the real world don't you want to keep duplicating code? Yes.
If you want to change it, you only have to change it in one place.
Very good. If you want to change it, you only want to change it in one place. Guess what? You are going to very often be maintaining someone else's code, and someone else is going to be maintaining your code. Well, you may remember that you wrote the same code in 3 different places, but the poor person maintaining your program doesn't know that. A bug report comes in, they fix one of the 3 places in your code, and they say, oh, I fixed it, they release it, and 24 hours later, another bug report comes in saying you didn't fix it. Yeah, I fixed it, here's my fix. And then you go back and then you start cursing. Let's say I was the original person. You say, that Brad, why did he write the same code in 3 different places? His bug is in 3 different places in the code. My boss is now mad at me because I didn't fix the original bug I thought I did. But that idiot Brad, if he'd simply put the code in a function, when I made the fix, I would now be looking good with my boss. But no, he had to duplicate the code in 3 different places, and he duplicated the bug in 3 different places. And now I am the one who am getting hosed by my boss because he thinks I'm incompetent rather than that original programmer, Brad the idiot, being incompetent. That is why you don't duplicate code. You put it in a function because when you duplicate code, you also duplicate your bug. Okay? So if you put your code in a function and there's a bug, at least it's only one place. And when someone fixes the bug, it only has to be fixed in one place. That's the other reason you write functions. So we're not just beating on you to write functions because it makes your code look good. It makes your code a lot easier to maintain and debug. Okay? Questions about TopCoder? You will be using TopCoder in the lab from now on, so TopCoder should work without much no, that's not really true. You may actually have to download it on the Hydra machines as well. My recommendation is that you get it to work on your machine. I think you'll be a lot happier if you get it to work on your machine. If you could not get it to work on your machine, Ben can help you tomorrow in lab, although he'll have limited ability. There's like 30 of you in each lab, so he'll be kind of spread across things. So it'd be better if you could try to get it to work tonight if it did not work, and if not, Ben can try to help you in lab tomorrow. Okay? Or we also do have office hours from, I think, 2 to 5 today, so you could also go into office hours. Okay, we good? Okay, so let's move on and talk about string streams and command line arguments. So I had to reboot. I had this up earlier, and I had to reboot my machine right before my previous class, and so I wasn't able to get. Okay, let's start with command line arguments. So when you run a program from the command line, sometimes you will give it arguments. So I might say, for example, for Palindrome, and I might give it a what's called a command line argument. In fact, I can give it multiple command line arguments. Okay, that might be, so this is 1, 2, so 1, 2, 3, 4, 5 command line arguments. So just like you can call a function with arguments, you're allowed to call main with arguments. So when you execute the program, you would like to be able to pass arguments in to main. And that's what I was doing there. I was passing 5 arguments to main. In order to handle those command line arguments, you must declare 2 parameters for main. The first is the count of the number of arguments coming in, which by convention you name it argc. And the second is an array of strings, which is your command line arguments. And that is you do it as char star argv. Unfortunately, they do not come in as C++ style strings. They come in as old style C strings. We won't really worry about that because there's an easy way to convert a old style C string to a C++ string. But this is the way you declare the 2 arguments. So you have a count of the number of arguments, and you have essentially an array of strings. So this might be whatever Brad, say 10, and true. And everything is a string. Even if you enter it as a number, it comes in as a string. Okay, now, your arguments that you provide start at 1 because the system always puts the name of the file into argument 0, which in this case it would be faux palindrome. Generally, you do not need to access this first argument. You don't care about the name of the file. So the user-supplied arguments start at location 1. Okay, so here's just a very simple program that iterates through the array and prints out each of the command line arguments, including the first one. Okay, so I could write such a program very simply. In fact, I think Dr. Planck may have already done it for me. If he hasn't, I'll write it quickly. But he did it for me. How nice. So I'm going to call it arguments.cpp. What's the name of the command to do indenting? gg equal g. Okay, so I'm going to compile it into a file called arguments. Going to run it. Need to declare main as an int. Okay, compile it. Run it. Give it some arguments. Brad 10, 20, true. And you can see the first one was actually the name of the file, /arguments, and then the rest of them were the names of my arguments. I can put them in quotes so I can get something longer like Brad Vanderzanden. I can use single quotes, so if I want to say Brad said, "How are you?" And it can get more complicated. Dr. Planck had something where you do some cute concatenation stuff. So Brad said, "How are you?" And then without ever missing a beat, he had a quote. Let's see, how did he do this? This was it. This thing right here. He said, quoting, "It is quite confusing." And it turns out this is a single command line argument. You might think that this string ends right here. Right? Because there is the end of the single quote. So you might think, wait a minute, doesn't the string end there? And then you might think the second string goes to right here because that's where the double quote ends. Then you might think that this is the third string right there. However, he did not put any space between those three strings. And since he didn't put any space between those three strings, they get concatenated together. So this string comes down to here, like that. Then it gets concatenated with this string. So this one goes from here to here. And the final string, which is in quotes, gets mapped to here. So if you don't put spaces between your quotes, the strings just get concatenated together. Does that make sense? Questions? If you do /n, well, we can try it. So where do you want me to put the /n? Let's do that and...
You're escaping it, right? Isn't that all you're doing?
So you want me to put a \n here? Okay, let's try it. In that case, it's just treating it literally, not doing you any good. Other questions? Okay. So when you do a command line argument, here it is right, well, hers is, whoops. Again, you give the name of your command, which normally has to have a ./ in front of it, and then your command line argument separated by spaces. And if you want a command line argument to have spaces in it, use quotes. Either single or double is okay. So arguments are always passed to main. You don't have to declare main to take them, in which case they're ignored. But if you do declare them, the first is always an integer denoting the number of arguments. The second is always an array of strings. Okay, we won't worry about that just now. So if you want to do something other than printing them out, just do this. Let's say the first one was string name. You could just say string name equals argv1, and that will automatically convert the C style string to a C++ string. So this statement converts the C style string to a C++ string. Did I see a hand up or not? Nope. Good. Okay. So that's pretty much it for command line arguments. It's just a way to pass arguments to main. Okay. No questions about that. We'll talk about string streams. I know if you've had me before, you've seen it, but 2/3 of you have not had me before, so 2/3 of you have not seen this. And for those of you who had me before, it's not a bad thing to have a little bit of review. Okay. So, here's the problem we often run into, which is that for the most part in 102 and 130, you did not do line-oriented I/O. Instead, you simply read in one value at a time using Cn. But a lot of programs use what's called line-oriented I/O, which means that each piece of data or each line refers to a different object. In this case, I have a file of scores for students in a course, and this is their score on the various exams. So on the first line is Mickey Mouse, on the second line is Donald Duck, on the third line is Winnie the Pooh. And what I want to do is read the exam scores for each student and print their average. Well, there's a bit of an issue, which is the number of exam scores is variable. So in some cases it's 2 and in some cases it's 3. So you can't very well assume that there's only 2 exam scores. If you do, and you read the 2 exams for Donald Duck, and the next thing you try to do is read a name, you'll get 63. That's no good. So you might say, okay, I'll assume that everyone has 3 names. Well then, for Mickey Mouse, you read 78 and 95, and then when you try to read Mickey's third exam, you get Donald. That's no good. So what we need is a way to read these things a line at a time. But if we read them at a line at a time, we also need a way to chop them up into their individual fields and convert them to the appropriate type. In this case, the exam scores need to be converted to an integer. Okay, so this just says why Cn fails, which I just told you why. If you try to write a Cn statement to read into first name and last name, and then a second line to read exam 1, exam 2, and final, it bombs out on Mickey Mouse. Right? When it tries to read final, what does it read? Just told you, but what's it trying to read when it reads final? The Donald. But unfortunately, that's not an integer, and your program Cn gets jammed, and then you'd have to do some stuff. So that's no good. So the solution is to read a full line of input using a function called getLine, and then to break the line of input into the different fields, which you do using something called Stringstreams. So the syntax for getLine is you give it a stream object, which is either Cn or the name of a file, and the second argument is the string variable that the line should be placed in. So it reads a line, it puts the line into the second argument. So here, getLine Cn puts a line of standard input into the variable named line. Here we have a file called from file. GetLine from file, it reads a line from file and puts it into the string variable named line. So that's our first problem solved. When getLine reaches the end of the file, it will fail and return false. So getLine returns true if it succeeds and false if it fails. So at the end of the file, it will return false. Okay, second thing we need to do is chop the line into fields that we can use. And we do that by stuffing the line into something called a Stringstream object. So we have IOStream objects, we have FileStream objects, and we have Stringstream objects. Stringstream objects are what we use to manipulate strings and break them apart. And we can use the greater than operator to extract the individual words from a string, or we can use the less than operator if we're trying to create a formatted string. Okay, so string streams behave just like cin and cout in that they use the same operators, and you can test them for EOF just like you can for cin and cout. If you want to use string streams, you must include them. The name of the library is SStream, so be sure to include that. If you don't, you'll get an error message. If you want to use a string stream for input, you use an iStringstream object, and it has actually 3 methods that we care about. str, which allows us to stuff a string into it. Greater than operator, which reads the next field from it. And there's a fourth one. I thought I had the thing. Do I have it? Nope. There's a fourth one called clear, which clears the string, which you have to do before you reuse it. Clears the string out of the string stream object. If you don't do that and you try to stuff another string in there, it doesn't work. Must call clear before reusing. And I know I'm going through this fast. I will post these slides. So you must call clear before you reuse the string stream object. That's a common mistake, is to forget to do it and just call string again. So here's how I use the iStringstream object to solve my exam problem. I start by declaring an array of size 3 because that's the maximum number of exams I'll read, and some other variables. I declare iStringstream buffer, and then strings to hold my first name, last name, and a line. So I read a line. I stuff it into the buffer. That's wrong. I have to use the string command to stuff it in there. So I stuff it in there using .str. Then I read out the first name and the last name. And now I don't know how many exams I have, so I write a while loop. But I do know that the remaining items on the line are exam scores, so I say while I can read another exam, I do so. I increment my count of exams, and I add that exam value to sum. And when I reach the end of the line, then the read operator fails and returns false, and I exit my loop. So this handles either the case where I have 2 exams or the case where I have 3 exams. Okay, and then the final statement is to average them together. So questions about that? Okay, that worked for a single line. Let's say that I wanted to read the entire file, then it's a little different. Now I have to say while getLine because I'm reading the entire file. Now before I call my string command, I need to clear it. Okay, but everything else is the same. Okay, so that's going to read everything, every line, and print out the average for each student. What thing did I fail to do here that I need to also remember to do? I cleared the buffer and stuffed the string in, but I'm going to find that my average is not calculated correctly after the first person. Why? I didn't reset, not average. I didn't reset sum and count. So I also have to remember to set sum equals 0 and count equals 0. Otherwise, things won't go so well for me. Okay? So you can also create formatted output strings. Honestly, how often have I used this in my life? Never. So it's in Dr. Plank's notes, and I figure you should see it. So if you want to create a formatted output line and put it into a string, you would declare an OString stream object, and then you would write to it just like you would write to cout. And if you wanted to get the formatted string out of there, you would call str. Okay? So, I believe, just hold on. We got one more slide, and I still got one more minute. So here's one that's creating a formatted string for time. I want to create time in the format hour, colon, minute, colon, SS, and then space hours. So I take 3 parameters. I create the OString stream time. Then, just like at cout, I write into it hours, a colon, minutes, a colon, seconds, and the final string, space hours. And finally, I return time.str. That returns the formatted string I just created. Okay, so that concludes our kind of whirlwind tour of string streams and command line arguments. Hopefully, for the most part, that was reviewed to you. But if it isn't, as I say, I'm going to post those notes and also make sure you read through Dr. Plank's notes. And on Thursday, we will be covering vectors of vectors and procedures.